Yeah. Good afternoon, everyone. Thank you for joining this session. My name is Oluwapelumi Aderemi, and today I'll be speaking about the topic innovating user experience with Flutter, building the next generation of cross-platform applications. Uh, Over the past few years, the expectation for digital experiences have changed a lot. Users are no more satisfied with apps that just do what they're expecting it to do. They expect the interfaces to feel in a certain way, natural, respond instantly to um, and adapt to what they want. They're already expecting something that's called intuitive design. Uh, and they expect it to deliver consistent experience across the mobile app. And then when they switch to maybe their web and their desktop, they are also able to still uh, feel have the same feel and flow of using an application. So creating that level of polish and polished applications uh, at scale when you're developing big projects and you want to do that on a mobile desktop and other interfaces is is um is no longer like something that you just want to you might just want to do. It's now compulsory. It's a requirement for every application these days. So this is where Flutter comes in. It's a framework that is that it started as a mobile framework, but now it has evolved into being a multi-platform user interface engine that's capable of creating seamless experiences on various devices and interfaces. It can work for your web, it can work on Windows, on Mac OS, uh, Android, and the likes. It even works on embedded systems as well. In 2025, Flutter is even bigger now. It's pushing the boundaries of what it can do, and it's enabling developers to innovate faster, to ship products on different devices. Um, and still ensuring that the design is user friendly, enhancing the user experience of of the application. So what we'll be doing today, we'll be talking about how Flutter has become a central part of building next generation cross platform applications, and we'll look at how it's modern, the rendering engine, how it's evolved, the ecosystem, and integrating with cloud native and AI power tools, um, and all of that. We'll be looking at all of this, and then by the end of this session, you will understand why Flutter is not just replacing systems like React for mobile application, but it's here to actually help developers build applications that are scalable and are able to work on various devices. So let's look at the evolution of cross-platform development. So uh, for us to understand why Flutter is so important today, it's important to look at how cross-platform development has evolved over the years. So in the early days of mobile development, where applications were built natively, you build for maybe iOS using Swift, or you build for Android using, say, Java and now Kotlin. That's the early days of mobile development. Native development offered great performance and it was full access and it offered us full access to hardware features, but it came with a major drawback that everything had to be done and has to be built um, twice, basically. What we mean by building twice is if you wanted to build an application, for example, that run on iOS and also run on Android, you have to build two different applications, one for iOS and one for Android. Now, it's there are many organizations that still follow that approach, but it's for big organizations that are able to manage two different teams that are working on these projects. And then you have to still make sure that it's in sync. You have to also make sure that when you're building uh, a feature for say iOS, you must also think of how you're going to integrate it for Android as well. And it always affected timelines, always affected, the teams, and then there's different bugs that are affecting one system. So maybe one system is running fine, the other one maybe they still has some bugs. You have to fix the bug that then push them out together at the same time, and that's quite cumbersome for a small team. So to solve this, the industry moves towards hybrid frameworks that use technologies like Ionic and Cordova, and this framework they allowed developers to build the application, just one application that was able to work on different mobile platforms, and they wrap it up in a single mobile shell basically. So it improved the development speed, but the user experience had to suffer because this hybrid applications were not able to respond to some native things. The native applications were able to target some key hardware functionalities that these hybrid applications could not just do. The animations were slower. It was just really cumbersome. Really large applications were built, and it was not very user friendly. It was affecting the user experience basically. So this led to the rise of even better cross-platform frameworks, where we saw React Native was designed to basically you're able to build applications uh, um, using like your web framework, but we're able to run on mobile devices, and it's actually did much better than the predecessor. They were able to target more native hardware, and then the UI rendering was a little bit better, but it was still not consistent between different platforms. You have to think about how it will work on Android, for example, and then how it will work uh, on iOS as well. So that's where Flutter then came in. Flutter came in and it has a different approach to solving this problem. Instead of relying on the native UI components, it renders, its entire interface using high performance engine. And this gives developers, perfect control, smooth animations, and consistent behavior across iOS, Android, and even web platforms using just one single code base. So with one code base, you're able to um, develop applications that will run on multiple devices and they will run seamlessly. The user experience was also much greatly improved, and we're able to target hardware facilities on different devices using just one code base. So the pain points that were solved that have been solved by Flutter, include you don't need that JavaScript bridge anymore. You don't need we can use just one unified widget system for consistent UI. So we have just that same UI that will run on Android and also run on iOS, and it will work perfectly because we're not building um, an, we're not constrained to the uh, the devices capabilities. We're using Flutter's own engine. It has stronger support for animations, and reliable development experience and all of that. That's what Flutter actually started with, and it kind of like came to solve that problem first, but it has grown more. So today, Flutter is even doing even more than that now. It's helping product teams to move incredibly fast. We're able to serve multiple business needs using just one code base, and with integrating when we're able to integrate our APIs, it feels like as if we develop native applications basically because of the Flutter engine. So what makes Flutter unique in 2025? First is this single code base that I already mentioned. You know, uh, so uh, basically you have one code base to develop, and then that code is able to work on different devices, like I mentioned. It's also uh, uh, um, it's able to kind of, with the new improvements like on Flutter 3.22, um, we're able to see like advancements, and we're able to do uh, more internal, we're able to target more native uh, systems on this application, on these devices. For example, when Flutter first came out, or most cross develop cross platform frameworks came out, they were not able to target, say, for example, the cameras of this of iOS, but they were able to do it on Android. But with the newer improvements to Flutter 3.22, we're able to target um these more functionalities from from both devices. Basically, we're also able to use Material 3 with Flutter. Material 3 is Google's material design that's able to, just helps with the user experience in terms of colors, in terms of adaptive components, and just helps to improve the user experience basically. Um, and one of Flutter's strongest qualities is the performance. When it comes to pixel perfect control, it's unlike your typical hybrid framework that rely on web views. Flutter renders every pixel on the screen using its own rendering engine. So this gives developers, precise control over layout, over animation, visual fidelity, and things like that. The result is that you have native level performance across devices that you don't necessarily feel like you're using a a cross um uh a cross platform framework. So it aligns with this aligns with their the Flutter's larger vision of, you design once, you deploy it anywhere in 2025, and so you're able to like have a unified design language. You're able to implement features once, and then you have just one code base to debug basically and test, run your maintenance, uh, and all of that. So you can see Flutter in 2025, we have a single code base, we have performance and pixel perfect control. Design once, you can deploy it anywhere on embedded systems, on desktop, web, iOS, Android, on any platform basically. You're also able to implement Material 3. So looking at the core principles of Flutter UX design. So number one is the declarative UI. So instead of manipulating UI elements step by step, we're able to simply describe what the UI should look like and its current state, and then Flutter handles the rest. So that makes the UI predictable for the user. It's easier to reason about, and also it's much more simpler to test it because you're just declaring things. It also allows for widgets composition. So the power of this leads to like cleaner code, more maintainable interfaces, faster iterations, and easier collaboration across teams. It also encourages design systems and component libraries, ensuring consistency, branding across mobile, web, and desktop interfaces. A responsive and adaptive layout. So like I've been saying, works on mobile phones, adaptive on tablets, on laptops. You're able to design it to just one code base, and you're able to still design it um, to adapt to any screen size or any device that you want to deploy it to. Um, and there's a picture of how you can style your applications to look on phone, on tablet, and laptop. Um, Devices. They're all different, but with Flutter, we're able to target each device specifically and then um, determine how it will look, the layout basically. So why are we designing a future, generation? applications using Flutter. So basically, the modern users, they expect the experience that go beyond static screens. They expect real-time updates. They expect smooth transition. They expect micro interaction with their applications. They expect the digital environment that feels, um, fluid, and be able to navigate things seamlessly. So Flutter is uniquely positioned to deliver all of this because of its rendering capabilities. Is able to, and it gives you tight control over the UI layer. One of the biggest shifts in recent years is to move towards real-time interactions, um, whether it's live location updates, collaborative editing, live chats, streaming. Users expect changes to appear instantly, and Flutter is able to enable that. It's reactive. It's a reactive model, and it's efficient as rendering pipeline um, that allow for UI updates to happen at 60, even 120 frames per second. So it's making real-time interactions feel seamless. And it's, when you combine it with API, combine it with WebSockets, Firebase, and GraphQL subscriptions, Flutter apps can perform, can give you instant feedback and, give dynamic content without any lagging or dropping of frames that you might find in older systems. So another major area where Flutter shines is animating every user interfaces, modern applications that use animation not just for declaration, but as part of the overall user experience. Flutter is also integrates very well with next generation animation tools like your Rive, your Lottie, and the Motion. With Rive you can now create interactive state-based animations that respond directly to user actions. Um, Flutter is able to support motion layouts and custom animations. Builders are able to give designs, and then they have more they have freedom. They have more freedom in their designs to create elements, that appear, that disappear, or transform on the screen, using motion and Flutter together. So using these tools to build with Flutter, we're able to build immersive, and fluid experiences for applications that stand out in the app market, um, where you're able to combine Flutter's rendering engine with modern motion design. So that's like taking it a step further, and then it feels like it's a native application. Whereas you design it with Flutter and it's running on iOS and running on Android, and it feels the same way, like you've designed two different applications basically. So that's why you can see a lot of large companies now and independent companies are using Flutter these days because of that flexibility that it gives you. You don't have to have two different teams on two different code bases. You don't have to test and debug. You just have to create it one time, and then you're able to deploy it on different systems. So so Flutter is not just a framework that is just for building applications, it's for building, experiences. That's what we're talking about in national applications. It's able to build experiences, that are responsive, that are expressive and immersive, that like the user can actually feel like they are actually interacting with these applications. We have a multi-device experience continuity. So this year we've seen like one of the biggest expectations of users is now, experience continuity. So they don't use their applications on just one device. You might be using your application, you might start using it maybe on the mobile, and then maybe you need to do something else using the web or desktop version of the application. Flutter comes in here because you have users that are using different devices. So it's not just building applications that work on the mobile app, that also work on the web, also work on the desktop or embedded systems. You're building applications that still feel like you're still on the same place, even though you've changed devices, basically. And you're able to do this with Flutter, you know. Um, you have a single rendering that's able to share widgets that can work on Android and on iOS, on Chrome, on Windows, on all these various platforms. So your animations, they remain the same. basically. You don't have to like build for your mobile app and maybe say you build for Android, then you have to think of how you're going to make that same animation on iOS and then that same animation on the web. You're just doing it one time and you have Flutter's engine is the one that is going to control everything basically. And the animations, the control, the interactions will feel the same regardless of whatever device the user is using. So we're also able to have adaptive layout systems, platform specific UX differences. So basically, these systems are different. They have different capabilities. So with Flutter, we're not going to worry too much about what one can handle or what the other one cannot handle. With Flutter's engine will help us to, you know, um, just build basically on the engine itself, and then it will then run on whatever application whatever device that we um, deploy it to. So how does it support multi-screen journeys? We have shared logic across platforms. We have consistent component libraries. We have identical animation and motion behavior. We have unified layout and styling rules. We also have easy deep linking, and also we have support for PWAs um, and native installs, basically. So it's important because it supports your, higher support. Sorry, supports cost. Basically, you don't have to hire many developers to develop every for every um, device. There's no confusion for the users. They're able to use the app the same way. They're able to duplicate the testing efforts. You also have fragmented development teams and all of that. We are able to have just one team develop everything, basically. So integrating AI for smarter UX. So as we move deeper into the future of applications, we are starting to see applications that are actually predicting users, are able to predict what the user will do using AI, basically. So one major shift is that you cannot really ignore that systems need to be intelligent enough to understand like when a user has done something, he is able to know, okay, what he's going to do next, or when he doesn't do something, maybe prompt him to do what he has missed in the past. We're able to do that now using AI. And how does AI integrate with, say, Flutter applications? Um, so Flutter supports Gemini, basically supports the Gemini API. Google's Flutter is developed by Google. Gemini is also developed by Google. So these advanced AI models are able to integrate very well with Flutter. With the Gemini AI, we're able to integrate natural language understanding, text generation, image analysis, um, reasoning directly into, reasoning into our Flutter applications, and it opens the door to intelligent, chat interfaces. We're able to do personalized content generation as per the user's needs and the user's uh, uh, demographics, basically. Wherever user is using our application, we're able to give them automated summaries and generate content for them, maybe based on their age, based on their locality or whatever. And we do this. We don't need to use too much code to do this because we're using machine learning and AI. And it also works very well with Firebase machine learning kits. It's able to offer, on-device machine learning capabilities, includes text recognition, image labeling, object detection, and the likes. Basically, you're able to detect people's faces, observe what language is being used, uh, and for trust, and also translate languages, basically. So the features, they operate locally on the device, so that means they are fast. We're not using um, um, any online or no need for any web connection or anything. So it's fast, it's secure, and and also works without your internet connection, basically. So it's good for industries that like to keep um, uh, their data more closely managed, healthcare, finance, and education as well. So, on the also it's on the device inference is important in 2025 because you can see instead of relying solely on cloud-based APIs, the apps can now embed small, highly optimized models directly on their user's device, and then it reduces latency, keeps it secure, dimension. So let's look at a few practical um, examples of how AI can enhance UX. It can work for smart text completion. So when the user is typing, we're able to predict what is going to type. Like we're seeing now on emails and messaging applications, just predict what you're going to type next. We're able to integrate this with Gemini into Flutter. Um, there's also predictive UI where the app is able to rearrange itself basically, and it prioritizes what elements the user is going to use based on what they've been selecting. So you're using less code here. You're just using predictions, AI predictions based on what the on how the user is, interacting with the application. It makes it more, it improves the experience for the user basically. Can automate image tagging, can also do have recommended widgets and all of that pop up for the users and all of that. And so basically, just making intelligent applications that are able to deliver consistently, cross-platform, on different devices, basically, whether it's mobile, web, desktop, or any platform basically that the user is using. So AI driven UX, it's not just like, you know, not something like it's not longer futuristic. Now it's here right now, and then we're expecting it to even grow bigger as um technology continues to advance. So users are expecting the applications to, you know, they're expecting a certain level of user experience, and they're also expecting the application to be intelligent, you know, to generate interfaces on it, or be able to predict what the users will do to interact with the system and all of that. Yeah, this is a diagram showing the AI architecture in Flutter application. We have the Flutter UI layer, and then it's able to integrate, you see, your own device inference, like just a small um, custom code that will run basically the application. Then we have your cloud AI services. That's where you reduce the number of code you have to write basically, and by using the AI to predict what the user is doing, it makes it feel more intuitive, more intelligent basically. So Flutter plus modern backend architectures. So when we're talking about next generation applications, we have to understand that your your design that using Flutter, is no longer just a toolkit. Basically, you know, it's able to allow developers to build experiences that are not only visually impressive but also scalable. Scalable in the sense that you're able to add more features easily. You're able, it's resilient. It's able to adapt to user needs and then growing ones of users as well. And it's also intelligent basically. So for the backend for Flutter, we're able to integrate with GraphQL, and GraphQL basically gives us precise control over the data that we are able to fetch basically. Um, it reduces the bandwidth usage and speeds up, UI rendering, especially for complex interfaces. So it's very good for dynamic data like say social media kind of like data, text. When you know really know what to expect, basically, it's when we use GraphQL. We also integrate very well with REST API. We use Flutter HTTP clients, such as the authentication headers, interceptors, caching. Um, we're able to do retries and also structured error handling. handling. So REST is simple. It's simpler than GraphQL. We're able to predict what we're asking for, what data we're working with, and it's good for consumer applications that that have been built today as well. So it's high performance for real time scenario. It also supports gRPC, which uses binary transport and strongly typed contracts. It's especially useful for streaming data, for multiplayer games, for financial dashboards and IoT systems, basically. We also have serverless backends. Flutter pairs very well with serverless platforms like AWS, Lambda, Cloud Run, Firebase functions, and the likes. This backend, the scale on demand, which means your Flutter app can support thousands or millions of users without you having to manage any server, basically. Uh, Also integrate very well with microservices. You're able to connect it using different APIs. And then in this model, each service handles a specific function, authentication, payments, search, recommendations, chats, um, notifications, all of that. We're able to integrate it easily with Flutter as well. So you also have your real-time database, your Firestore and all of that, and offline um, strategies are also able to work. You can use your system preferences, you can use local caching, synchronized background, and all of that when developing with Flutter. So this ability, to connect, modern back-end architecture from using your REST, your gRPC, GraphQL, Firebase, microservices, is position Flutter Flutter developers for like true end-to-end architecture architecting and not just you know not just doesn't just make you just look like you're just doing UI designing. No, you're able to actually like control how the app functions behind the scenes as well using Flutter. So performance and optimization with Flutter. So when we talk about this, we're talking about like Flutter gives us strong um access to performance, to just give us a way to using the auth reload and all of that. We're able to see how the app is performing as we're even developing it. At a high level, it uses its own rendering pipeline basically instead of relying on the OEM widgets and all of that. Flutter can draw every pixel itself. Using rendering engine. Traditionally, we used to use third-party applications, but with Flutter's engine is very powerful and we're able to do um, rendering using Flutter. And it means the animations will be smoother because we don't have to like test it somewhere, then come back and write more code and all of that. It's smoother because the engine is powerful enough to test it by itself and then continue writing and makes it all seamless and all of that. From a developer's point of view, it's good at minimizing unnecessary re-rendering of widgets of pages and things like that because it's declarative, and then if you put too much logic basically into a single widget, it's able to minimize it. It's able to know like there's no need for XX, and because we already have this, the engine is that smart to understand that not make us to re-render what's already been done already. um Makes the application even feel smaller as well. We we we're able to split your UI, your widgets, into um, different instances, basically using constructors where possible, and then we're able to push the state down to the to narrow the scope, basically using your provider, your river pod, and all of that, to isolate the updates, basically. So it also shines in very well in memory management. You know, Yeah, we when building Flutter applications, we basically using the Dart programming language, which is also a garbage collection. Basically, we are still able to clean up after like building the application. We're able to clean the stream, the controllers, the focus node, and all of that. But that helps us to like minimize the size of the application, basically, reducing wastage and all of that. Um, we're able to do all of this and it improves the performance, helps you to optimize it. Basically, the application is very efficient. It's not um it's not skipping on things that just make that are just there to just increase the size of the application uh, 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 as such, basically. Um, so further makes it very easy to add animations. It's also easy to that's in the aspect of optimization. You know, so we are able to like build widgets, keep the animation logic simple, the profile, and the performance and the tool using Flutter Dev tools. We're able to like keep it to a minimal using Flutter, and then so we also have a financial. Sorry, finally we also have the efficient network handling um, which we always see when we're trying to build high performance UX. So batch requesting, using pagination, debouncing, search or type ahead calls, basically using Flutter. So when you put all of this together, we're able to say that Flutter is good as a very strong rendering pipeline. It's able to leverage the um, its engine to minimize the renders. You can manage memory correctly, caching intelligently, animating responsibly, and all of that using Flutter. So just look at a few case studies where I've used Flutter in the past. So um, we developing Go Together is a cross-platform social matching experience that's able to work on mobile applications, on mobile devices, sorry, and also able to work on web interface as well. So basically, it's like I said, it's a social matching application, and it's designed for students, professionals that want to connect based on shared interests. And when designing is one of our biggest challenges was we're trying to create real-time interactions and seamless user journey across mobile and web. So while keeping the application fluid, so we wanted when you switch from your mobile phone to using the web application, wanted to feel like you're still using this application, doesn't feel different, even though you're using a different device. So that's why we chose to use Flutter. We had one single code base across all platform, and I was able to design unified experience. The interface for swiping through matches, viewing profiles, and all of that, sending requests, feel identical on both devices, and on all devices, Android, iOS, web platforms. They don't have to learn a new layout when they switch their devices. Everything works together. And then one of the major focuses on this was also real-time user engagement. So we're able to use the cloud-connected architecture using Firebase for authentication and for live updates. We integrated AWS microservices, for scaling backend features. So Flutter Reactive UI model allowed us to allow the interface to update instantly when new matches appear, when people pair with each other. Um, there's no lag, there's no need to refresh the page like we've seen in some older applications. Using Flutter, we're able to do that. It's able to refresh itself once there's a new match, and it also improves continuous interaction and all of that. So another area where Flutter really shines, is we're able to create custom, interactive UI elements, the matching interface. We're able to create animated cards for the mobile device. I wasn't even not thinking about we're going to do it also for the web. Still the same UI elements were still implemented on the web as well. So helps for movement transition, micro interactions, and everything we just built using Flutter, one code base, and the app look modern, polished, and then users were able to recognize that okay, this application is the same when they're using their mobile or their using the web version as well. So beyond the real-time features, um, we also had architecture that's also able to support, cloud scalability. It communicates with microservice based backend that is now running on AWS EC2 instances, and we're storing, images and other similar types of data using S3 buckets. So Flutter integrates cleanly, easily with REST APIs. So you have a modern front end that is able to um, fetch matches, update preferences, and sync very easily with user data, and also reliable. We're also able to implement um, AI um, for um, for predicting the correct matches, not just relying basically on what the users have mentioned in their demographics. Basically, we're also able to um, predict um, uh, what kind of people would like to match with other people using AI capabilities, basically. So the future of Flutter and user experience. So as we continue to look ahead, and we can see that Flutter is not just a toolkit that is for today for building um, um, powerful applications. It's rapidly becoming one of the most influential platforms, shaping the future of user experience across devices. The first area where we're seeing major innovation in Flutter integration is with AI workflows, with tools like Gemini API, Firebase, ML Kit, um, on-device inference engines, and all of that. We're able to use do create AI driven features um, with Flutter applications now. So it means the experience is more predictive, it's more intelligent. We have text assistance, we have real-time personalization, we have adaptive UI behavior, and all of that have been built into applications now using Flutter's um, ability to work very well with uh, AI tools. So we also have embedded systems. Basically, we're able to use Flutter on embedded devices. You can run on your embedded system that like with your car, with your home appliances, POS, terminals, and all of that. IoT dashboards and all of that. We're able to do all of this with Flutter these days. So it's become a very powerful tool basically over the years, from its inception until now, and it's continuing to grow. So it's a very powerful tool basically. It's also good for web assembly improvements, good for design systems and automation tools as well. So that's the end of the lecture. So I hope we've been able to explore what Flutter is. Um, that it's no longer just a cross-platform um, framework with applications that have evolved into a powerful, you know, foundation for next generation applications, multi-platform innovations, um, able to integrate very well with AI, machine learning, and we can also build one code base that is able to run on various devices, basically. So it's a very powerful tool that can help us build beautiful UX user experiences. Um, but not just the user interfaces alone. We're able to still, you know, target native architecture of these devices, and then they all feel very native. Thank you very much for listening.